Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from z equal to e power x f of y plus e power y into g of x by eliminating the arbitrary functions f and g. So here we are asked to form a partial differential equation from this equation by eliminating this f and g, which are the arbitrary functions. Okay, let's see. Given z equal to e power x f of y plus e power y into g of x, right? Consider it as some equation number 1. Now let's partially differentiate it with respect to x. We'll get dou z by dou x equal to partial derivative of the RHS part with respect to x, right? So here f of y is treated as constant. Since we are partially differentiating with respect to x, so we'll treat y as constant, right? This gives us constant into partial derivative of e power x is e power x plus constant e power y into partial derivative of g of x is g dash of x, right? Since we have a notation dou z by dou x equal to p, let's replace it by p. You'll get p equal to e power x f of y plus e power y into g dash of x, right? Now consider as equation number 2. Let's partially differentiate 1 with respect to y. Okay, here we need to write partially differentiating 1 with respect to x. Now partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. You can do directly. So since we are partially differentiating with respect to y, we'll treat x as constant. Here in the first term e power x is treated as constant. Constant into partial derivative of f of y with respect to y is f dash of y plus constant g of x is constant into partial derivative of e power y is e power y, right? Since we have a notation dou z by dou y equal to q, let's replace it by q. We'll get q equal to e power x into f dash of y plus e power y into g of x. Consider as equation number 3. Now again we'll find r, t and s if we feel it's necessary. Let's see. Fine, now let's find r. Okay, you can also write r as dou by dou x of dou z by dou x, right? That is partial derivative of here dou z by dou x is nothing but p, right? So partial derivative of p with respect to x gives r. Now partially differentiating with respect to x. This gives us dou by dou x of p equal to dou by dou x of e power x f of y plus e power y g dash of x. See here, it's not necessary to write dou by dou x on both sides of 2. Just to avoid error, we are writing it. Okay, this gives us dou p by dou x, which is nothing but, here you'll get dou p by dou x, which is also r. Okay, dou p by dou x is also nothing but r, but I'll replace this p by dou z by dou x, the known term, right? This gives us partial derivative of with respect to something with respect to x, right? So here we'll treat y as constant. So f of y is constant into partial derivative of e power x with respect to x is e power x plus here e power y is treated as constant into partial derivative of g dash of x is g double dash of x. This gives us dou square z by dou x square equal to e power x f of y plus e power y into g double dash of x, right? Which gives us, since we have a notation dou square z by dou x square equal to r, let's replace it by r. You'll get r equal to e power x f of y plus e power y g double dash of x. Consider it as equation number sum 4. We got p, q and r. Right, now let's partially differentiate 3 with respect to y. What is t? We have t equal to dou square z by dou y square, right? Which is nothing but dou by dou y of dou z by dou y. Also, you can write dou z by dou y can be replaced by q, which is dou q by dou y, right? So t is nothing but partial derivative of q with respect to y. So if you find partial derivative of 3 with respect to y, you will get t. Now we need to find t, right? So what I'll do is, I'll partially differentiate this 3 with respect to y. Dou by dou y of q equals to dou by dou y of RHS part of q, that is e power x f dash of y plus e power y q of x. This gives us dou by dou y of q is nothing but dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. So here in the first term e power x is treated as constant, and here g of x is treated as constant. We'll get constant into partial derivative of f dash of y is f double dash of y plus partial constant into, g of x is constant, right? G of x constant into partial derivative of e power y with respect to y is e power y, right? This gives us dou square z by dou y square, right? Dou square z by dou y square equal to e power x f double dash of y plus e power y into g of x, right? Since dou square z by dou y square equal to t, let's replace it by t. You'll get t equal to e power x f double dash of y plus e power y into g of x. Consider as equation number 5. So we got equation number 5, t equal to e power x f double dash of y plus e power y into g of x, right? Now we need to find partial differential equation, right? Observe equation 2, 3, 4 and 5. In equation 2 we have f of y and g dash of x, and here you have f dash of y, g of x, f of y, g double dash, f double dash and g, right? I think it's not possible to find partial differential equation using this 4, so I'll find s also here. S is nothing but dou square z by dou x dou y, right? You can partially differentiate p. This is nothing but p, right? Okay. Yeah. You can partially differentiate q with respect to x to get s, or you can, so you'll get dou square z by dou x dou y. Or you can partially differentiate p with respect to y. P is nothing but dou z by dou x, right? This gives us dou square z by dou x dou y. Either you can partially differentiate q with respect to x, or you can differentiate p with respect to y. So let's go for q. Partially, you'll get the same answer by doing q with respect to x or p with respect to y. You need to get the same answer. Partially differentiating, I'll show you. Partially differentiating 3 with respect to x. So dou by dou x of q equal to dou by dou x of the RHS part of equation 3. This gives us dou by dou x of q is nothing but dou z by dou y equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. F dash of y is treated as constant, here e power y is treated as constant, right? Constant into partial derivative of e power x with respect to x is e power x plus constant into partial derivative of g of x with respect to x is g dash of x. This gives us d dou square z by dou x dou y equal to e power x into f dash of y plus e power y into g dash of x. Since we know that dou square z by dou x dou y equal to s, so we'll replace the LHS part by s. You'll get s equal to e power x f dash of y plus e power y g dash of x. See, we got f dash and g dash here. Okay, let it be. Now we got s equal to e power x f dash of y plus e power y into g dash of x, right? Now I'll show you how to find s using p, that is partial derivative of p with respect to y also. See here, in order to find s, we can find or we can pick any of these two formulae. Okay, fine. Now let's partially differentiate 2 with respect to y to find s. Let's see what happens. E power x f of y plus e power y into g dash of x, right? We know that p is partial derivative of z with respect to x, and here we are partially differentiating with respect to y, so we'll treat x as constant. Here in the first term e power x is treated as constant, in the second term g dash is treated as constant. We'll get constant into partial derivative of f of y with respect to y is f dash of y plus constant g dash of x into partial derivative of e power y with respect to y is e power y, right? We can write this as dou square z by dou x dou y equal to e power x into f dash of y plus e power y into g dash of x. Since we have dou square z by dou x dou y equal to s notation, right? Just replace it by the notation. See, we got the same answer, right? So you can pick any of these two to find s. Remember that it's not necessary to find both, you just need to find s. So for that you have two formulas, you can pick any of these two. Fine, now we got p, q, r, s and t. Now using these 5 equations, consider some equation number 6. Using these equations, we need to find partial differential equation by eliminating f and g. Let's see that. See, we have 5 equations p, q, r, s and t. What I notice is s have the same pattern, e power something into f dash plus e power something into g dash. I'll pick this s. S equal to, we have s equal to e power x f dash of y plus e power y g dash of x. In order to find partial differential equation from this, we need to eliminate f dash and g dash, right? So I'll observe the remaining. Actually I have observed all this and I have fixed what to do. Fine, now if you notice, you have p equal to e power x f of y plus e power y g dash of x. From this you can find the value of e power y g dash of x, right, which we need. So we have p equal to e power x f of y plus e power y into g dash of x. This gives us p minus e power x f of y equal to e power y g dash of x. So you can just replace this e power y g dash of x with p minus e power x f of y. You need to practice in order to get that idea, okay? You won't get in just one shot. You need to practice. Now, again, I'll try if I can get the value of e power x into f dash of y. Yeah, I notice that q is having e power x f dash of x, right? So what I'll do is, I'll just find the value of e power x f dash of y using this equation 3. We have equation 3, q equal to e power x f dash of y plus e power y q of x, right? So from this I'll get equal to q minus e power y g of x. Okay, now I'll just replace these two by these values, since e power x f dash of y can be replaced by q minus e power y g of x, and e power y g dash of x can be replaced by p minus e power x into f of y using or by 2 and 3, right? So we have equation number 6, right? Now this gives us s equal to, just replace it by q minus e power y into g of x plus, replace the second term by p minus e power x into f of y. Also here we have to notice that we have equation 1 z equal to e power x f of y plus e power y into g of x, right? Here we need to notice that we have minus e power y g of x and minus e power x f of y, right? By taking minus from these two terms, we'll get z using 1. Let's see how we'll get it. S equal to q minus e power y g of x plus p minus e power x f of y. Okay, this gives us p plus q minus e power x f of y minus e power y g of x. I wrote p first and then q and then term involving e power x and then term involving e power y, right? Now what I'll do is, I'll just take minus common from the last two terms, so that I'll get minus of e power x f of y plus e power y g of x. We have seen this somewhere, right? Which is z. Since z equal to e power x f of y plus e power y into g of x. So what we can do now? We can just replace it by z. This gives us p plus q minus z. So we got s equal to p plus q minus z, right? Which is a partial differential equation of order 2, right? Fine. Therefore, s equal to p plus q minus z is the required partial differential equation. And this completes the problem. Okay, you can also write this equation as, you can bring this z to LHS, you'll get z equal to, and take this s to RHS, p plus q minus s. Some may like to write in form of z equal to, so you can write this like this also. You can write the equation like this also. Fine. So we got the answer, s equal to p plus q minus z, which is the required partial differential equation. See, all you have to do is, you'll just find p, q, r, t in every problem, and you'll observe, you can do a trial and error method to find partial differential equation with these 4 equations. And if you feel that it is not enough, I mean these 4 equations are not enough to find the required partial differential equation, then we'll find s. Okay, so see, after finding s, we can understand by looking at the equation that it involves the same pattern. See, this has e power x f dash of y, and here also the same pattern, it involves e power y and g dash, right? and here what we have to do, always will eliminate f and g. So here we'll try to eliminate f dash, and here we'll try to eliminate g dash, right? So we need the values of f dash and g dash. Simply find out the values of f dash and g dash using the remaining 4 equations. Is there any possibility using 4 and 5 can we find the values of g dash and f dash? No, it's not possible, because equation 4 has g double dash and equation 5 has f double dash. It is not possible, right? Then look here, we have g dash and f dash, so there is a possibility. Okay, just write one step, and the next step you'll automatically do with the help of, you can write the next step automatically with the help of the remaining equations. Okay, all you need to do is just observe. You can't solve this problem easily just like that. Okay, all you need to do is observe R, S, T, P and Q, or P, Q, R, S, T. Fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.